All right, everybody, so we're going to take a look at this first problem here. This first page, actually, on this honors physics review exam. This is something you did last year. I want to make sure that you're fluent in it now. So imagine a fox darting around in the woods for several hours. Can the displacement ever be larger than the total distance traveled? The answer is no, never. Delta x is, again, x final minus x initial, whereas distance is the total length traveled. So as it turns out, delta x, the displacement, is always less than or equal to the distance. So for example, if I start the fox, say, here, and the fox winds up here, that's the displacement. And the distance is this whole length of the path that the little fox travels as it moves. Now, what's the difference between average and instantaneous velocity? Average velocity is the total displacement divided by the total time elapsed. Okay. In the instantaneous velocity, we're going to tighten up this definition. So the total displacement over the time elapsed is delta x over delta t. And the instantaneous velocity means the velocity and you know what? There's a lot of room here, so let me be really clear. I want to actually type this one out a little bit more carefully, or write it out a little bit more carefully this way. So here's what we'll say. Again, instantaneous velocity, average velocity, delta x over delta t is the average velocity. Okay, that's the displacement over the time. The instantaneous velocity is the velocity at a particular time. So I would say, if I wanted an example, this is what the speedometer reads. It reads the velocity at that time. This is the total displacement divided by the trip time. Now we're going to tighten up our definition of instantaneous velocity to actually be, so if we have the position as a function of time, in AP Physics we're going to tighten up this definition that the velocity is the derivative of the position with respect to time. Okay. Now, it says, give an example where an object could have negative acceleration while also speeding up. So that would be moving in reverse while gaining speed. That would be that particular example. So that is page 1, or problem 1, on the first homework of the year.